Have you ever watched an airplane soar through the sky? It's a truly breathtaking sight, isn't it? The way these massive machines lift off the ground and glide gracefully above us can seem almost magical. Whether you're standing at an airport, gazing up from your backyard, or watching from a window seat, seeing an airplane in flight always sparks a sense of wonder and curiosity. How do they do it? What makes them rise so high and travel so far, carrying people and cargo all over the world? It's amazing how these big machines can climb, descend, and even turn. Airplanes are designed to move in all directions, up, down, left, and right, thanks to some clever engineering and powerful engines. Pilots use a variety of controls in the cockpit to guide the airplane smoothly through the air, making sure every flight is safe and comfortable. But have you ever wondered what's really happening when a plane changes direction or altitude? There's a lot more going on than meets the eye. Just like birds use their wings to fly, airplanes need special parts to control their movement in the air. Birds flap and tilt their wings to soar, dive and turn, using their feathers and muscles to steer. Airplanes, on the other hand, rely on carefully designed parts that mimic the way birds move. These parts help the plane stay balanced, change direction, and adjust its height in the sky. Without them, flying would be impossible. One of the most important parts is called the elevator. The elevator is a special control surface located on the tail of the airplane. It might sound like something you'd find in a building, but in aviation, the elevator has a very different job. It helps the airplane move its nose up or down, allowing it to climb higher into the sky or descend gently toward the ground. Without elevators, pilots wouldn't be able to control the pitch of the airplane, which is essential for safe and smooth flying. Imagine you're holding a kite on a windy day. The wind tugs at the kite, making it dance and dip in the air. You have to pay close attention to how you hold the string, because even a small movement can change the way the kite flies. Flying a kite is a lot like flying an airplane in some ways, because both require careful control to stay up in the air and move where you want to go. To make the kite go higher, you pull the string back. This changes the angle of the kite, catching more wind and lifting it up. You can feel the tension in the string as the kite climbs, soaring higher and higher above your head. It's exciting to watch as your kite responds to your touch, just like an airplane responds to the pilot's controls. To make it go lower, you let the string out a bit. The kite dips and glides gently back toward the ground, following your lead. By adjusting the string, you're actually changing the kite's angle to the wind, which is very similar to how a pilot uses the elevator to control an airplane's pitch. It's all about balance and making small adjustments to keep everything flying smoothly. Airplanes need a way to go up and down too, and that's where elevators come in. When a pilot wants to climb, they pull back on the control yoke, which moves the elevators and raises the airplane's nose. To descend, the pilot pushes forward, lowering the nose. This simple movement is what allows airplanes to take off, land, and adjust their altitude during flight. It's a crucial part of every journey through the sky. In the next section, we'll learn exactly what these elevators are and where to find them on an airplane. We'll take a closer look at how they work, why they're so important, and what makes them different from other parts of the plane. You'll even get to see real examples and discover how pilots use elevators every time they fly. So if you've ever been curious about the secrets of flight, you're in the right place. Get ready to learn about the magic of flight. There's a whole world of fascinating science and engineering waiting for you. And it all starts with understanding how airplanes move through the sky. So buckle up, open your mind, and prepare for takeoff as we explore the wonders of aviation together. You won't find these elevators taking people between floors. On an airplane, the elevators are small, movable parts on the wings or tail that help control the plane's up and down movement. They're like the flaps on a bird's wings, helping it to climb or descend. Most airplanes have their elevators on the horizontal part of the tail, called the horizontal stabilizer. Think of the tail like a big fin that helps keep the plane balanced. The elevators are like smaller flaps attached to this fin. Now you know where to find them. But how do these simple flaps actually control a giant plane? Let's find out. Remember our kite example? When you fly a kite, you're not just watching it dance in the sky. You're actually controlling its movement with your hands. The way you pull or release the string changes how the kite moves, letting it soar higher or dip lower. This simple action is a great way to understand how airplanes control their movement in the air, especially when it comes to climbing or descending. Pulling the string changes the angle of the kite, making it tilt up or down. When you pull the string tighter, the nose of the kite points upward, catching more wind and rising higher. If you let the string out, the kite's nose dips and it starts to descend. This is all about changing the angle and how the air flows around the kite. Elevators on an airplane work in a very similar way. They're small, movable surfaces attached to the horizontal part of the tail, called the horizontal stabilizer. Just like the string controls the kite, the pilot uses controls in the cockpit to move the elevators and change the plane's angle in the sky. When the pilot wants the airplane to climb, they pull back on the control yoke or stick. This action moves the elevators on the tail upward. It might look like a small movement, but it has a big effect on the airplane's flight path. This upward tilt of the elevators doesn't push the plane up directly, like a rocket. Instead, it changes the direction of the airflow passing over and under the tail. The air hitting the upward tilted elevators is deflected downward, which in turn pushes the tail of the airplane down. This movement creates a difference in air pressure. There's lower pressure above the tail and higher pressure below it. The result is a force that pushes the tail down. As the tail goes down, the nose of the airplane points up, and the whole aircraft starts to climb higher into the sky. You can see this in action when a plane takes off. The nose rises, the tail lowers, and the aircraft lifts off the runway. The elevators are doing their job, helping the pilot control the pitch, or up and down angle, of the airplane. To make the airplane descend, the pilot does the opposite. By pushing the control yoke or stick forward, the elevators tilt downward. This time, the airflow is deflected upward, which pushes the tail up and causes the nose to point down. This reverses the process. The tail rises, the nose dips, and the airplane smoothly descends toward the ground. The pilot can make small or large adjustments, depending on how much they move the controls, allowing for gentle descents or steeper dives. It's all about controlling the airflow and pressure around the tail. By adjusting the elevators, pilots can make the airplane climb, descend, or maintain level flight. This simple but powerful system is what lets airplanes move gracefully through the sky, just like you guide a kite with a string. We've talked about elevators on the tail, but did you know that not all airplanes follow this classic design? While the majority of aircraft you see in the sky have their elevators at the back, controlling pitch from the tail, some innovative planes take a completely different approach to flight control. These unique designs challenge the traditional setup and offer a fascinating look at how aircraft can be engineered for different purposes and performance needs. Instead of placing the elevators on the tail, these special airplanes have their control surfaces mounted at the very front of the fuselage, just ahead of the main wings. These forward-mounted surfaces are called canards, and they function a bit like a duck's bill, hence the name, which comes from the French word for duck. The canard configuration is easy to spot. Just look for small wings or fins near the nose of the plane, sticking out in front of the main wings. We call these front elevators canards. They might look small compared to the main wings, but they play a crucial role in controlling the aircraft's pitch and stability. Canards are especially popular on experimental planes, advanced fighter jets, and some high-performance civilian aircraft. Their placement at the front of the plane gives designers new ways to balance the aircraft and improve its handling. Canards work in a similar way to tail elevators, but with a twist. They control the airflow in front of the wings instead of behind them. This means that when a pilot adjusts the canards, they directly influence how air flows over the main wings, which can help prevent stalls and improve maneuverability. In some designs, canards can even make the plane more stable at high angles of attack, which is especially useful during takeoff, landing, or sharp turns. When the canards tilt up, they generate lift at the front of the plane, pushing the nose upward and causing the aircraft to climb. This action is similar to what happens when a traditional elevator on the tail moves, but the effect starts at the front, giving the pilot a different feel and sometimes quicker response. Tilting the canards downward has the opposite effect. It reduces lift at the nose, causing the front of the plane to dip and the aircraft to descend. This precise control over the nose's position allows for smooth climbs and descents, and can make the plane more agile in the air. The idea of using canards isn't new. Some of the very first powered airplanes, like the Wright brothers flyer, used a canard configuration. Over time, the design has evolved, and today you can find canards on everything from experimental home-built planes to cutting-edge military jets. Each use case takes advantage of the unique benefits canards offer, such as improved stall resistance, better visibility for the pilot, and sometimes even increased fuel efficiency. While most airplanes have elevators on the tail, canards offer some unique advantages in certain designs. For example, they can help keep the main wing from stalling by stalling themselves first, which acts as a natural safety feature. They can also allow for more creative and efficient aircraft shapes, which is why you'll see them on some of the most advanced planes in the world. Whether it's for agility, safety, or just to try something new, the canard configuration shows how creative engineers can be when designing airplanes. It's all about finding the best way to control the plane's movement in the air, and canards are just one of the many fascinating solutions in the world of aviation. Remember how we said the horizontal part of the tail is called the horizontal stabilizer? Well, that name gives you a big clue about its job. The stabilizer's main purpose is to keep the plane flying straight and level. It's like the keel of a boat, providing stability in the water. While the elevators are responsible for making the plane go up and down, the stabilizer helps prevent any unwanted pitching, like, the nose moving up and down during flight. It keeps the plane stable so it doesn't bounce around in the air like a bouncy ball. Working together, the stabilizer and elevators ensure a smooth and controlled flight. It's all about teamwork. Some airplanes are designed with efficiency in mind. Instead of having separate elevators and ailerons, the parts that control rolling, they combine the two into special control surfaces called elevons. Elevons are located on the trailing edge of the wings and can move independently. When one elevon goes up and the other goes down, the plane rolls. But when both elevons move up or down together, they act like elevators, controlling the pitch of the plane. It's kind of like having one tool that can do two jobs. This simplified design helps reduce weight and drag, making the plane more agile and fuel efficient. Remember how birds can change the shape of their wings while flying? Well, scientists and engineers are working on some really exciting new technologies that will allow airplanes to do the same thing. Imagine wings that can bend and twist, adapting to different flight conditions. This futuristic concept is called morphing wings. Instead of using separate control surfaces like elevators and ailerons, morphing wings can change their entire shape to control the plane's movement. This could lead to smoother flights, improved fuel efficiency, and even quieter takeoffs and landings. While morphing wings are still in the early stages of development, they represent the future of aviation. The journey to controlling flight has been a remarkable one. Early pioneers like the Wright brothers experimented with simple flaps and levers to control their first airplanes. Over time, these control surfaces became more sophisticated, leading to the development of elevators, ailerons, and rudders. As technology advanced, so did our ability to control airplanes. Modern jets use hydraulic systems and computers to make precise adjustments to the control surfaces, allowing for smoother flights and greater maneuverability. And with advancements like fly-by-wire systems and now morphing wings on the horizon, the future of flight control is full of exciting possibilities. From the first tentative flights to soaring through the skies in modern jets, elevators have played a crucial role in making air travel possible. These small but mighty control surfaces might seem simple, but they are essential for controlling an airplane's up and down movement. Whether they're located on the tail, the nose, or even integrated into a morphing wing, elevators help pilots maintain control, ensuring a safe and smooth flight for everyone on board. So next time you see an airplane, take a moment to appreciate the unsung heroes of flight control, the amazing elevators.